Good morning, ladies and gentlemen, and welcome to Remote Wednesday lesson number 2. We are in solving multi-step equations, day number 8, and we're going to begin solving equations that have expressions with distribution, or where we may choose to use the process of distribution to help simplify the expressions within the equation. By the end of the lesson, students should be able to identify opportunities where they can clear parentheses, and that's going to be the process of sharing multiplication of a coefficient of a grouped quantity into its terms. And we're going to do that to begin to simplify more complicated expressions. Most often, simplifying expressions within equations begins with clearing parentheses if there's an opportunity to do so. So we'll see what those opportunities look like today. Please understand that we are on virtual Wednesday, and the lesson will be found in Delta Math. It will record and track your progress. Attendance will be taken based on that, and there will be a classwork grade assigned. I am going to need you for this particular assignment as we move forward to be sure to complete the classwork and homework and submit them as a set of pictures in one assignment together. That way it makes it a little easier for me to keep track of everything that's going on. Make sure that you've also submitted the homework from last night. That was under collecting like terms, and technically it was last Friday's assignment. We were a little bit behind with some of the classes, so we bumped it up and we're trying some new techniques, so that allowed us to fill the time effectively. It can be found in the classwork under the tab for September 25th, last Friday. Remote Students Period 3. The packets for the next 2 weeks are available at the front desk, and I highly recommend that you try and pick them up today. That way you're ahead of the game and you don't have to try and squeeze in over the next few days. I will also have that available on PDF in the classwork section if you're able to print that at your house. Ladies and gentlemen, I swear, everything is just fine. Can't you tell by my expression? And the secret, in case you're wondering of how we're going to get through the year, is that the plan is that there is no plan. That's not true. We're working on it. Essential questions will be question number 2, 3, 4, and 7 in the classwork. There's a couple others I'm going to have to touch on, and if we have time, I'll come back to some of the additional ones. But I do want to be conscious of how long this takes. That way I'm not taking up too much of your time. If we take a look at the class stream super quick, you'll notice that the assignment for Virtual Wednesday is the very first post within the stream. You can click on that. That will take you to the appropriate location to hand that assignment in. Actually, for me, that takes me to your work. So let's go back for just a moment into the stream. If you also were to look in your classwork tab, you can find it as the very first assignment at the top of the classwork. I think that I have to reverse this possibly and put the most important or daily assignments up top. I'm going to have to see how that works out. I'll get your feedback when we return to class. But you would click into that assignment and it would take you to the appropriate section where you could find the instructions, where you'll be asked to submit a picture of both your classwork and your homework together. And it's the physical pages in your packet, 14 and 15. If you're working off the PDF, it's pages 27 through 30. In addition, if you ever get lost, please try and get in the habit of going back to the agenda for the week. So if you're lost and you're not sure where things are, you can click into the Google Doc and review some of the important topics for the week, scrolling onto the second page with some of the important considerations of the week, and scrolling into the second page and finding where we are in the chart or the matrix for the week. So we are on Virtual Wednesday. We will be solving multi-step equations using distribution according to the topic. We will have to complete examples such as the one shown here. It is page 15 in the packet for homework, and you'll be required to do both front and back. It's pages 29 and 30 in the PDF for the homework itself. With that being said, let's get started right away because this can be quite a lengthy lesson, and I want to make sure that we try and use your time as effectively as possible. Ladies and gentlemen, today solving equations using distribution. I'm going to work rather quickly through these examples. Number one is kind of the introductory question where the content is simple enough that it should make sense. So in question number one, ladies and gentlemen, we're asked to solve this relationship where the expression on the left with the appropriate value for x would be equivalent to 55. Very difficult to guess, so we're going to try and use correct mathematical steps. If you had looked at this and you said, dude, shouldn't I undo the addition with subtraction? And wouldn't it be a good idea to subtract 4 from both expressions? You wouldn't be wrong, but please don't do that. That is not necessarily the most effective tool to solve this most efficiently, but it's not wrong. Technically, that is the additive property of equality. Remember, subtraction is the same as adding the opposite, and we could add whatever we want to an equation as long as we do it equally on both sides. However, I'm going to suggest that to keep things simple and so that you're kind of following the same process no matter how complex an equation gets, that you choose to begin by clearing parentheses whenever you're given that opportunity. Clearing parentheses is going to involve a situation where you have a grouped quantity. In this case, we have the x plus 2 being multiplied by a coefficient. So technically, at some point, we want you to triple the value of x plus 2. And if you think about what that means, and again, you don't have to write this, you can just watch for a moment. If you think about what it means to triple x plus 2, you could argue and say, Tooch, doesn't that simply mean that I have x plus 2 and another x plus 2 and another x plus 2? And shouldn't I add that together? And wouldn't that technically be 6 if I add the numerical quantities? And 1x plus 2 more would be a total of 3x's. And shouldn't the portion of that first term of the expression be equivalent to 3x plus 6? And the answer is yes, it should. But what we want you to know is that when you have a coefficient outside a grouped quantity, technically you can simply multiply into the grouped quantity. And you would draw these arrows to indicate that you want to triple everything inside the grouped quantity, therefore tripling the entire grouped quantity. And in this instance, 3 times x would be 3x, and 3 times 2 would be 6. Then you can continue to add the 4, and that would equal 55. Now, technically what you would do at this point, and especially if we were operating in some other country systems where they show all the mathematical steps, technically they would force students to put a set of parentheses around 6 and 4, 6 plus 4, the numerical quantities. That would change the order of operations, and it would force them to collect like terms before they proceeded through the question. You guys don't technically have to put the parentheses there. If you just underline the quantities and say, hey, Tooch, I'm going to use the associative property of addition and choose to add 6 and 4 first, now that would make sense to me. But it is technically the associative property of addition, which says you can group quantities within an expression being added or multiplied, or you can regroup them in any manner you choose, and you will not change the value of the expression. Remember, if your parents say, I don't like who you associate with, they're talking about your group of friends. And we group quantities in mathematics using parentheses. So you can change the manner of parentheses throughout an expression. Whenever you're managing addition or multiplication, you will not change the value of the expression. From there, it becomes a two-step equation. In a two-step equation, our goal should be to undo order of operations or PEMDAS, to reverse engineer the relationship, working backwards. And we begin by undoing addition and subtraction first. You should add negative 10 to both expressions. That's going to allow you to remove the 10 from the expression with the variable in it. That way we can simplify and see, have a better interpretation of what x may be. You might have said, Tooch, aren't you subtracting 10 from both expressions? Yes, technically we are, but you know that subtraction is the same as adding the opposite. And that also allows us to see this as the use of the additive property of equality. Technically, if we're adding negative 10 to both expressions, you could say you can add whatever you want to an expression as long as you do it equally on both sides. You'll not change the relationship, you'll just make it look different. By the way, any amount plus its additive inverse, positive 10 plus negative 10, will always equal 0. So we're choosing to use the additive inverse as part of the additive property of equality to simplify the expression to better see that 3x equals 45. And at this point, many of you could guess what the answer is because it's just suggesting that if you triple some amount, it will equal 45. And if you divide out the coefficient of 3, undo multiplication with division, you could determine that x equals 15. Please remember that what you have here in that last step is the use of the multiplicative property of equality, which says you can multiply an equation by whatever you want, as long as you do it equally on both sides. And you might say, well, Tooch, that doesn't look like multiplication to me because we actually just divided by 3, so why are you saying that? And the truth is, division is the same as multiplying by the reciprocal. So we could have shown that as multiplying by 1/3 in the expression on the left and multiplying by 1/3 in the expression on the right. And fractions have denominators, and denominators mean divide. So 3 would divide into itself perfectly one time in the expression on the left, leaving us with 1x. And 3 would divide into itself once and into 45 15 times, leaving us with 15. So it is important for you to understand, and I'll try and show that in the next example if I have an opportunity to, that division is actually use of the multiplicative property of equality, and we can show that by multiplying by the reciprocal. You can multiply an expression by whatever you want, so long as you do it equally on both sides. Cool. So the answer should have been 15, and technically we should check it, but I completely ran out of space there, and I'm sure you did too. So we'll perform the check in one of the questions to come to make sure. You really should be checking all of your relationships once you solve them to make sure that you've solved it correct. And I'm going to clean up the page so we can see it a little better in the next relationship. In the next relationship, the next equation, ladies and gentlemen, my hope is that you will put up a fence, stay organized in your work, And as you do that, we're looking for some expression that if we find the appropriate value for x in this complex relationship, we can evaluate the expression on the left and it will equal 16. That may be a good opportunity to check in just a moment. What's tricky about this particular question, and the reason we have to do this, is because this is one of the ones that trips students up a lot. From 8x, we're subtracting the entire quantity, 5x plus 2. That means we're not only subtracting 5x, but we're also subtracting 2. Now that can be a little confusing, and one of the easiest ways to manage it is to put a coefficient of 1 in front of the grouped quantity. And then you'll recognize that you're subtracting one whole value of 5x plus 2. And that would allow you to distribute the negative 1 and say, well, why don't I share the multiplication of negative 1 into the grouped quantity and clear parentheses, and that should make things clear to see. That would leave us with 8x and minus 1 or negative 1 times 5x. Negative times a positive is a negative. And negative 1 times 2 would be negative 2. And we just cleared parentheses as the lesson's trying to instruct us to do. Technically, it would be wise to put a set of parentheses around 8x minus 5 to identify those like terms being put together. Like terms mean the same variable raised to the same power. At some point, we're going to be dealing with more than x. We're going to have x and y and z and a and m and all kinds of things going on. So in those expressions that have more variables or more letters, it's going to be important to recognize we can only put the same letters together raised to the same power. And the same power is going to get tricky rather quickly too, because we're going to have x to the first. This is technically x to the first. It's called a first degree polynomial. We'll deal with that later on. But there will be x to the seconds and x to the thirds and so forth. Like terms have the same variable raised to the same power. We could have used the associative property of addition. Well, teacher, we're subtracting there. Yeah, but technically we could have rewritten it as 8x plus negative 5x because subtraction is the same as adding the opposite. And the associative property of addition says you can regroup in any manner you want within an expression to change the order of operations so that we can collect like terms. This leaves us with 3x less 2 equals 16. It's now a two-step equation. Two steps require us to undo two mathematical operations, and we typically choose to work backwards through order of operations PEMDAS and undo the addition or subtraction first. So we would want to add positive 2 to both expressions. That leaves us with 3x's equals 18, and at this point most of you guys know what the answer is. There's some number that when you triple it, it equals 18, and that's the same number that if we were to substitute into the original expression, would make the entire relationship in the expression on the left equal 16. You could undo multiplication with division, and you can divide by 3 in both expressions, or as I said a moment ago, you could choose to write the division as multiplying by the reciprocal. Division is the same as multiplying by the reciprocal. And you could choose to show it as the multiplicative property of equality. You can multiply an equation by whatever you want, so long as you do so equally on both sides. If you choose to show it as multiplying by the reciprocal, please know that 3 divides to 3 one time, leaving us with 1x in the expression on the left, and 3 divides into 8 itself once and 18 6 times, leaving us with 6. X equals 6. Cool. And the tricky part about that one, again, was distributing the negative sign into the grouped quantity because we were subtracting both terms, or as we sometimes like to say, distributing a negative 1. It's a good idea to put a 1 in between the negative sign and the grouped quantity so that you can see that more clearly. I'm only going to begin number 3 because I know that we're going to be running short on time, but I do want you to see what's different about it because all the steps at the end are the same as what we've already practiced. So number 3 gets a little bit more complex because, as you might notice, the expressions on both sides of the equation get a little more complex. And in this particular relationship, you're going to be forced to clear parentheses in both expressions. So you're going to have to distribute on both sides of the equal sign. To do that, it would be wise to organize your thoughts, and I like to say draw in the distribution arrows to show that when you triple in the expression on the left x minus 4, that you're not only tripling x, but you're also tripling the minus 4. When you triple x, you get 3x. When you triple minus 4, 3 times negative 4 is negative 12, and then you'd have to subtract 19. And that would be equal to the expression on the right. In the expression on the right, it's tricky because when you look at this, you have to understand that technically, I'm going to clear out some space so I can show the technically part a little more clearly. In the expression on the right-hand side, technically what you're managing is an expression that has negative 4 and negative 3 times x minus 5. So you have to remember, or you have to consider, that the operation minus 3 is really going to be interpreted as a negative 3. So the operation is going to be the sign of the number as we distribute into the grouped quantity, because we're subtracting 3 times the value of x minus 5. So in order to make sure that we account for that appropriately, you have to distribute minus 3. And I like to double underline it to remind myself that I have to distribute the negative sign as well. So I double underline both the coefficient of 3 as well as the minus sign. What we're left with is negative 4. Negative 3 times x is negative 3x. And negative 3 times negative 5, the sign is the operation of the number. We could rewrite it as adding the opposite, and you'd see that more clearly. But you should train your eye to understand that. Negative times a negative should be a positive. Now, technically, what should happen in these expressions, if we're using the appropriate mathematical processes so that we don't get confused when things get more complex later on, technically, we should take the minus 12x minus 19. It's really, subtraction is really adding the opposite, so this is really plus negative 19. And we really have a negative plus a negative is more negative, and we would get negative 31, where 31 is subtracted from the 3x's. Rewrite the expression appropriately. We would have used the associative property of addition by rewriting subtraction as addition. We could have regrouped those terms so that we would have taken care of that first. Most often what we really do is we just double underline negative 12 and minus 19. We don't even put the parentheses there, and we just say if we collected those like terms, those numerical values, that equal negative 31. But it is important to understand that that's a use of the associative property of addition. And the expression on the right, technically we should be moving the 15 behind negative 4, and we should have negative 4 plus 15 minus 3x. And that would be a use of the commutative property of addition. The commutative property of addition, the word commute means to move or change position. It says we can reorder addition throughout an expression and we will not change the value. Now, most often you guys just go, hey, Tooch, don't we have 15 and negative 4 in the expression on the right? Can't we put them together and get 11? Yes, you can. But you're supposed to, if we were doing all the steps, reorder the addition using the commutative property. Then you're supposed to regroup the addition using the associative property. Then you get 3x less 3 equals 11 minus 3x. And as you approach a two-step equation, you would now want to transfer a variable. Because there are x quantities on both sides of the equation, we'd like to use an appropriate mathematical stepper rule to get them in the same expression, on the same side. There are many ways to do this appropriately, but the most effective way is to use the additive property of equality and add the opposite of the variable quantity within the expression that has the lower coefficient. So although you could technically subtract 3x's from both sides to remove the 3x quantity in the expression on the left, I would recommend that you add 3x, the inverse of negative 3x, to both expressions. You can add whatever you want to an equation as long as you equal on both sides. In the expression on the right, positive 3x and negative 3x would cancel, and you'd be left with 6x minus 3 equals 11. And then we would solve a two-step equation. So there's a lot going on in there in terms of all the different details that we're supposed to be managing. I'm actually going to check to see how long the recording is to get an idea where we are. Oh my goodness, that's crazy talk. All right, I got to pick up the pace. I do want to solve number 14 only because I want to interpret the inequality appropriately. And in order to do that, ladies and gentlemen, we would put up a fence. I'm going to clear a little room from the relationship above so that you can see my work a little more clearly. And what I hope you recognize in today's work, and what may be new for some of you, and for a lot of you to review because you did do this in 7th grade, is that when you go to solve this inequality, what becomes a little bit complex about it is that you have opportunities to distribute in both expressions on either side of the inequality. In the expression on the right, that's probably the easiest one. You're doing 4 times the quantity x less 3. So you have to multiply x and negative 3 by a factor of 4 to clear the parentheses so we can begin to simplify this relationship. And we get 4x's less 12 plus 56 is greater than. And in the expression on the right, we would also have to notice that we're subtracting twice the value of 5 and 3x. So subtraction is the same as adding the opposite, and for that reason, we have to interpret this as negative 2x. The operation gets interpreted as a sign of the number. Bring down 13 in your expression. Negative 2 times 5 is negative 10, and negative 2 times 3x is negative 6x, and then we've got to add 7 to that. Now, I'm going to skip all the regrouping using the associative property and reordering using the commutative property, and do what many of you learned to do last year. Many of you learned to identify the like terms within an expression, and you probably circled or boxed them. I'm going to request that you double underline your first pair of like terms you'd like to put together on as you simplify one of the expressions at a time. You don't simplify them both together. And that's going to require me to do 13 less 10, that is 3, and 3 plus 7, that is 10, positive 10, minus 6x is the simplified version of the expression on the left. I've done all the operations I can up to this point. In the expression on the right, I would simply double underline negative 12 and 56 and do 56 minus 12 and rewrite this as 4x plus 44. So you don't have to actually show the commutative property where you're reordering everything throughout the expression of addition, and you don't have to show the associative property where you're regrouping everything, but you do need to know that that's what we're doing. Otherwise, when we get to the more complex relationships, it's going to seem a little awkward. From there, ladies and gentlemen, we would want to transfer a variable. You wouldn't be wrong if you said, hey, Tooch, can I subtract 4 x's from both expressions? Absolutely, that is an appropriate use of the additive property of equality. But I'm going to suggest that the easiest and least confusing way to transfer a variable to get your variable quantities on the same side of a relationship is to choose to transfer the variable quantity with the lower coefficient. So negative 6 is less than 4, and if I choose to transfer the negative 6x's by adding positive 6x's to both relationships, appropriate use of the additive property of equality, positive 6x and negative 6x are going to cancel. I use the additive inverse. Any amount plus its additive inverse will equal 0. And I get 10 is less than 10x plus 44. It's now a two-step inequality. Two steps begin with addition. I'm going to subtract out 44 from both expressions. And I'm going to get negative 34 is greater than 10x. I would then have to divide out the coefficient of 10. And I'm going to go into the next question because I don't think we're going to use it anyway. And I would get negative 3 and 4/10 is less than x. If I read it from the variable to the number, I get x is greater than negative 3 and 4/10. If that makes you uncomfortable, you could switch the order of the expressions, put the variable expression x on the left, put the numerical quantity on the right, but then make sure if you reverse the order of the expressions that you also reverse the sign so that it matches appropriately, and you can read it more easily. X is greater than negative 3 and 4/10. You'd have to identify negative 3 and 4/10 as close to as accurately as possible, somewhere between negative 3 and negative 4. Put an open circle, and all the quantities greater than negative 3 and 4/10 would be to the right. They'd be less negative, or they'd be positive. Cool, flip. And once again, I'm going to jump to number 7 because I'm concerned about time. And number 7 brings us into our word problem. Number 7, ladies and gentlemen, the word problems, as I've started to suggest, are some of the most important work we do all year long. It's a major part of your curriculum. We got to avoid them as kids. We just whined and complained enough, and we never really learned how to think because we didn't do the actual questions that were important. And this one is a little bit of a beast. The truth of the matter is we're going to see these two styles of questions separately in work to come. So the two styles of questions that you're about to see are an age question, which we'll focus on in an entire day, and a consecutive integer question, which we will focus on in a separate day in the weeks to come. They're slammed together here, and I'll help you get you started on it. I know that's going to be a little bit tricky for you to consider, but I want you to follow the processes of solving a word problem, which include begin by decoding, and then read the question as many times as you need to get a deep understanding of the relationships and to translate it into an appropriate algebraic relationship. So here's what we have. 3 brothers have ages that are consecutive even integers. Now, normally if you're in class, you'd say, ladies and gentlemen, how many brothers? And you'd all shout out 3 brothers. Consecutive even integers, that's some tricky detail. And again, we're going to spend a whole day on that specific verbiage because that's a little tricky to consider. 3 brothers have ages that are consecutive even integers, and the sum of the first and the third boy's age is 20 less than, less most often comes last, than 3 times the second boy's age. Find the age of each of the 3 boys. So that's a little bit of a beast, and that can be a little bit tricky to try and pull the pieces out, and that's why we're going to practice it in separate days' work. But here's what I know. There's a lot going on here. It's a little bit crazy, and there's 3 brothers' ages, and I don't know any of their ages. When I don't know mathematics, typically I call it X. So something's going to have to be X in just a moment, and technically because I have 3 boys' ages I don't know, I'm going to have to use that X multiple times to represent their ages. When I don't know an amount of mathematics, I typically call it x, and when I have a lot of work to organize, it's generally accepted throughout mathematics that you can write the word let to indicate that you have to organize your thoughts and you want to let people know what you're thinking. Since there are three brothers' ages and they're consecutive even integers, I know this. Not knowing any of the boys' ages and they're three and they're consecutive one after the other, somebody's got to be the youngest in the group. So I'm going to choose to call x the youngest brother's age. And the reason I'm going to call him the youngest brother is because as I build up the relationship describing the other brothers, they have to be even integers. So when we count by evens, 2, 4, 6, 8, 10, 12, we go up by 2. And if the boys have to be consecutive integers, then one of the boys would have to be x, and the other boys would have to be 2 greater each time. So if the youngest brother is x, then the brother after him, being consecutive, meaning right after, would have to be 2 years older. Since he's an even integer, I'm just going to add 2, count by 2s. That makes my even numbers go up. That would be middle brother. And if I need another brother whose age I don't know, I'm going to need a third expression describing his age. And since the brothers are going up by even integers, he is also going to have to also start at x, but he's going to have to be 2 years older than the middle brother. So the middle brother was already x plus 2. That's going to mean that the oldest brother is going to have to be x plus 4. And I know this is tricky, trust me. We're going to do a whole day on age problems, then we're going to do a whole day on consecutive integers. So for now, just practice the processes of solving a word problem. Underline, circle, star, important information. Read the question as many times as you need to. Set up an organizational statement, and hopefully put the appropriate relationships together. Three brothers, whose ages I don't know. I've represented as three expressions, x plus 2, x plus 4. Because their ages are consecutive, one right after the other, even integers means I must be counting by 2. Now, as I read the rest of the word problem to determine their relationship of those expressions, it says that the sum of the first and the third boy's age, so I'm going to take the first, who is x, and the third boy's age, who is x plus 4, is, small word with big meaning, that must be equals, 20 less most often comes last, so I'm going to be subtracting 20 at some point, then 3 times the second boy's age. So 3 times the second boy's age must be tripling x plus 2, and then less most often comes last, subtracting 20. That is not easy by any stretch of the imagination. That would be one of the toughest problems you've had to interpret all year long, and it allows us to see the use of distribution within a word problem, because we're going to have to triple the second boy's age in the expression on the right. That's going to require us to distribute 3 into x plus 2 and to get 3x plus 6. Then we can rewrite the minus 20. And if you'd like, you could drop the parentheses in the expression on the left, or you could say 2, since it's simply addition throughout that whole relationship, can I just add the 2 x's together and get 2x plus 4? If you wanted to, you could have rewritten that entire expression without the parentheses. That is also use of the associative property of addition, because you're just eliminating the parentheses in that instance. And you would have put parentheses around x plus x to get 2x. We didn't change the order within the expression. We just changed the grouping so we can see more clearly that we're putting the 2 x's together. But as you get better, you won't need to do those steps. In the expression on the right, technically you should put parentheses around 6 and minus 20. Technically, you should change subtraction to addition, so you can see that you would be using the associative property of addition in the expression on the right. 6 minus 20 is 6 plus negative 20. Subtraction is the same as adding the opposite. But it's fine if you just said, Tooch, I'm pretty good at this, and I know that I can do 6 minus 20 either in my head or on my calculator. And I know that 6 minus 20 would be negative 14. From there, you'd want to transfer a variable. You're not wrong if you subtract 3 x's from both sides. Technically, subtraction is the same as adding the opposite. You'd be using the additive property of equality to move or remove the x variables from one expression into the other. But I'm going to always suggest that if you choose to move or remove the variable quantity in the expression that has the lower coefficient, it'll be more efficient. You'll deal with less negative signs throughout your work. Positive 2x's and negative 2x's will cancel, and we'll be left with 4 equal to x. 3x's minus 2x's is 1x, less 14. Then we simply have to add 14 to both expressions, and we're able to determine that x would be 18. Now this is where you start seeing the exit pass. I start to ask you some really deep questions about your understanding of the problem, because honestly, the algebra without application, without being able to understand what you just solved for, is useless. So yeah, who cares about the imaginary three boys? Nobody. But the imaginary three boys at some point will be the level of interventions we give or steps in a medication process for somebody who's trying to get over, I don't know, Lyme's disease. You're going to have to give them a certain amount of a prescription, then you're going to have to give them 2 more units of it as they get further along and their body can handle it. Then you're going to have to give them 2 more units of it. If you've ever taken prednisone, that is a steroid that my wife just took it for poison ivy this summer. But prednisone, you start with actually a lot of the medication, then you work down so that your body can adapt to it. Many of the investigations in the world around us happen where there is some sort of pattern in the amounts that are missing that we're describing. So again, do we really care about the brothers' ages? No, but we will be able to apply that to many real-life situations as we move forward. So 18, ladies and gentlemen, is the value of x, and what's important to understand is that is the value of the youngest brother's age. And that's something you'd have to describe to me. If you add 2 to it, 18 plus 2 gets us 20, and that is the value of the middle brother's age. And if you add 4 to 18, you get 22, and that would be the value of the oldest brother's age. These can be crazy tricky because a lot of times you can get answers that make sense based on the work you did, but you may not have written the correct equation. So we'll work on these, and I think this is some of the toughest work that you do all year, is these complex word problems where there doesn't seem to be a lot of information, but you have a ton of stuff to decode and then solve appropriately. Ladies and gentlemen, today's lesson was on distribution. It was on clearing parentheses within expressions so that we can simplify those expressions and then solve the equation for a missing amount. We saw that there were a couple of instances where sometimes you have to distribute in both expressions, like in question number 4, to begin to simplify both expressions. We also saw that sometimes you can be distributing a negative because you'd be subtracting the amount of that grouped quantity being multiplied by the coefficient. So you have to be careful when you're distributing a negative. We also saw that sometimes you could be subtracting a grouped quantity, which would require you to distribute a -1, like in question number 2. Clearing parentheses, once again, allows us to continue to simplify each of the expressions separately, and then to solve a 2-step equation eventually by undoing order of operations. I hope that all makes sense and that you guys are able to do a good job on the homework. And if there are any questions, I'll try and respond to them as efficiently as I can. Please make sure that you take a picture of your classwork and you submit that in the same assignment along with the homework, which is on the following 2 pages. Good luck, and I will see you all in class.